Hello everybody, this is Bert Dixon here to talk to you about similarity in right triangles. Whenever we have an altitude drawn from a vertex in a right triangle, or drawn from the right angle in a right triangle, we get three different triangles that are actually all similar triangles. So I'm going to use my document camera to demonstrate how we can tell that those three triangles that we can see are similar. And so first, before we start working on the three different triangles, I want to point out that we always want to look at the diagram and see if there are any other side links that we can fill in. Here we know this entire hypotenuse is 64 and this small piece is 25. So if we subtract 25 from 64, we're going to get 39 for that length. And so now what I'm going to do is I'm going to use 3 pieces of tracing paper and trace each of the 3 triangles onto a different piece. So we have our big triangle, and I'm also going to label the side lengths here. So this one was labeled as X, and this side is 64, and we have our right angle here. Okay, so I'm going to take that triangle aside. Now I have 2 smaller triangles here. I have this triangle and its side is X and 39, and we have a right angle here. And then the third triangle is this one. And in that triangle, the only side that we know is the 25. Okay, so now I'm going to take those 3 triangles and try to orient them all the same way. So let's orient them so that our right angle is to the left, like this one, and the short leg is horizontal. So if I do that with this triangle, that would look like this. So I have short leg horizontal and the right angle here, and the longer leg is vertical. Okay, and then we can do the same thing with this piece. If I position it this way, the right angle's in the right place, but this isn't the short leg. The short leg's over here, so I actually have to flip my the tracing paper upside down, and so I'm going to rewrite the 64 so that we can read it because it's upside down the way I wrote it before. So now we have our 3 triangles positioned the same way. And notice that the this smaller triangle only has 1 side length given, whereas these 2 we have 39 and X. This one we have X and 64 that are in the same relative position. So when I orient them the same way, it makes it easier to set up my my proportion to solve. So I have the vertical piece 39 over the vertical piece X, so vertical over vertical equals hypotenuse over hypotenuse, so that's going to be X over 64. And so then when I cross multiply, I get X squared equals 64 times 39, and then we'll take the square root of both sides. And the square root of 64 is 8, and the square root of 39 cannot be broken down, so our final answer then is X equals 8 root 39. Okay, so back to this again. I wanted to show how we know for sure that these 3 triangles are all similar. And so if I put one over the other, we definitely have right angles in all 3, and if you can see as I slide these triangles around, that angle is exactly the same as that angle, and then in the lower right hand corner, this angle is the same as this angle. And so even though they weren't oriented the same way in the original diagram, they do all have the same angles, and we can do the same thing with this one. This angle up at the top is the same, and this angle down at the bottom right is the same. And so these triangles, these three triangles have the same three angles. And we can also mark that now on the diagram. It's a little bit harder to do without the pieces of tracing paper, but we can still do it. In the big triangle, this is my shortest side, so this is my smallest angle. And then in this medium-sized triangle, this is the shortest side, that's the same angle. And then this angle matches, this angle is in both the big triangle and this triangle. And so then this would be the same as this, that's short side, so small angle. And then this one is longer leg, so there's the larger angle. So now I have the three angles marked so you can see in the three different triangles which angles match up. Okay? So now we'll go ahead and try the same thing with example 2. We'll start with some new tracing paper. And first we're going to label the missing side here. So 81 minus 56 is 25. So this side length is 25. And so now we'll go ahead and trace our three triangles. We have our big triangle. This is 81 is our hypotenuse, and x is our long leg. There's our right angle. Okay, set that one aside. Then we have this medium-sized triangle. That's x, and this is 56. Set that aside. And then our little triangle, looks like this, and it has only one side marked. It is 25. So most likely we're not going to use this one because it only has one piece given. Okay, so let's just focus on these other two triangles. Now we want to orient them the same way, so I'm going to take this larger triangle and flip it over so that the triangles are oriented the same way. So the right angle is at the left and the hypotenuse is from the right. Okay, so now we can see right away that 56 over x would be the same as x over, this is 81. Remember, that's upside down. Upside down 81 looks like an 18, so we want to make sure we realize that's 81. So we have 56 over x equals x over 81, and so that'll be the proportion that we can write. So height 56 over height x equals hypotenuse x over hypotenuse 81. So notice I did small triangle over big triangle equals small triangle over big triangle. So small height over big height equals small hypotenuse over big hypotenuse. And now when I cross multiply, I get x squared equals 81 times 56. Take the square root of both sides. X equals the square root of 81 times the square root of 6. And square root of 81 is 9. And let's see, 56 is 8 times 6. We're looking for a perfect square that goes in there. So 4 divides in. And so you can split that up as 4 times, oh sorry, this is 8 times 7, not 8 times 6. And so we have 4 times 2 times 7, the square root of 4 is 2. So now we have 9 times 2 times 2 times 7 is 14. And so our answer then is x equals 18 root 14. The next two examples we're going to try to do without using the tracing paper and to see if we can orient our figures correctly by thinking in terms of long leg and short leg and hypotenuse. So every right triangle has legs, so we would call this one the short leg. This one would be the long leg. The legs make up the right angle. So those are the two legs, and then across from the right angle is the hypotenuse. So I'm going to constantly refer to those three terms when we're trying to set up our ratios here. Okay, so first we want to notice that in this triangle we have a right triangle and we know two of the sides, so we can get the third side. So we know both legs. We can get the hypotenuse by doing the square root of 16 squared plus 12 squared, and that is going to be the square root of 400. So if we call this side C, for example, we'd have C squared equals 16 squared plus 12 squared, so C equals the square root of 256 plus 144. That's the square root of 400, which is 20. So C equals 20, so now we know this side is 20. And in this smaller triangle over here, in this red triangle, we know two sides. We know x and 12, so that's short leg over long leg. So I can say short leg over long leg equals, now let's look at the blue triangle and do short leg over long leg. So the short leg is 12, the long leg is 16. So now I'm able to solve for x by cross multiplying. I'll get 16x equals 12 times 12, which is 144, and then 144 divided by 16 is 9. So x equals 9. Now let's try example. Problem 4 is very similar. We have two sides of this right triangle, and so we can find the hypotenuse using the Pythagorean theorem. So c squared equals 16 squared plus 4 root 65 squared. So c squared equals 256 plus 16 times 65. So c squared equals 1296, and c equals the square root of 1296, which is 36. So now we know this side is 36, and we can set up our similar triangle ratio. So let's see, in this red triangle, we have the short leg and the long leg. In the blue triangle, we have all three sides, so we can use the short leg and the long leg in that one as well. So if I do short leg red over short leg blue equals long leg red over long leg blue, and then cross multiply. 16x equals 16 times 65, so x equals 65. Now I'd like you to go ahead and pause your video player and try these two problems. Try problem 5 and problem 6 on your own. And when you're ready to check in and see if you got them correct, go ahead and press play whenever you're ready. For problem 5, we can find the hypotenuse of this small red triangle by doing c squared equals leg squared plus leg squared. So c squared equals 16 plus 48. C squared equals 64. So c equals 8. So now we know this side is 8. And since x is the hypotenuse in the large triangle, I'll highlight that in green. So the large triangle, we know the short leg and we want to find the hypotenuse. So short leg and hypotenuse. And in the red triangle, we know the short leg and the hypotenuse. So we can say short leg 8 over hypotenuse x, that's from the green triangle, equals short leg 4 over hypotenuse 8 in the small red triangle. And now when we cross multiply, we have 4x equals 64, so x equals 16. For problem number 6, we know a leg and the hypotenuse in this blue triangle. So we can find b using the Pythagorean theorem. 12 squared plus b squared equals 8 root 3 squared. So 144 plus b squared equals, let's see, that would be 8 squared is 64 and root 3 squared is 3. So 64 times 3 is 192. So now we have b squared equals 192 minus 144. B squared equals 48. So b equals square root of 48, which is 4 root 3. So side B is 4 root 3. And now in this small red triangle, we want to know the short leg and we know the long leg. So in the blue triangle, we know the short leg and we know the long leg. So we can say short leg x over long leg 4 root 3, that's all from the red triangle, equals short leg 4 root 3 over long leg 12 in the blue triangle. Notice another way to set this up, I could say short leg red over short leg blue equals long leg red over long leg blue, and we actually get the same exact equation, even though I went about the process of going through the triangles differently. So now when we cross multiply, we have 12x equals 48. 4 times 4 is 16. Root 3 times root 3 is 3. So that's 48. And so x equals 4. Okay, feel free to go back and watch any parts of this video again if you need to. Go ahead and try the exercises for today's assignment and come back to the video if you feel it'll be helpful.